Hey everyone, and welcome to this explainer. If you're gearing up for your ninth grade biology review, you have landed in the exact right place. Today, we are tracking the absolute fundamentals of our world, specifically how matter cycles and energy flows. It's basically the ultimate ecological engine, so let's dive right in.
First up, you've got to ask yourself, where does every single ounce of your energy actually come from? I mean, the energy you're using to sit up, breathe, and focus on this explainer right now. It actually didn't start with your breakfast. It originally came from about 93 million miles away, straight from the sun.
All right, let's look at how that happens in Section 1, Sunlight to Stored Energy.
Think of plants and algae as these incredible biological solar engines. Through the magic of photosynthesis, they take in some very specific inputs. We're talking light energy, water, and carbon dioxide. Then they completely rearrange that matter and transform the light into stored chemical energy in the form of sugar while outputting oxygen as a handy byproduct. It's really nature's way of saving power for a rainy day. That solar energy doesn't just disappear, right? It gets physically packed away into the chemical bonds of those new sugar molecules. You can kind of think of these bonds exactly like tiny microscopic storage lockers. As long as the bond holds shut, the energy stays safely stored inside. Moving right along to Section 2, Building Blocks of Life.
Okay, so to actually build a physical body, organisms take the basic elements from that sugar, the carbon, the hydrogen, and the oxygen, and use them as a core foundation. By snapping these together with elements they pull from their environment like nitrogen or phosphorus, they can synthesize the true building blocks of life. We're talking about complex molecules like amino acids, proteins, and lipids.
Which brings us to Section 3, Unlocking Energy to Live.
Now, the organism has all these energy-packed structures, but how do they crack them open to actually survive? That is where aerobic cellular respiration comes in. Conceptually, it's literally the exact opposite of photosynthesis. It breaks the bonds of food and oxygen molecules, resulting in a net transfer of energy that the organism uses to live. And if you think about the outputs, it releases carbon dioxide and water right back into the environment, perfectly mirroring the inputs of photosynthesis. It is a beautiful closed loop.
Let's zoom out to the macro level for Section 4, Energy Pyramids and Ecosystems.
When energy moves up a food chain, say a bird swoops down and eats a grasshopper, we see a massive drop-off. We call this the 10% rule. Only about 10% of the energy actually transfers up to the next trophic level. The vast majority of it, well, it's either used up by the organism just trying to live its life, or it simply radiates out into the environment as heat.
And because of this dramatic drop in energy transfer, ecosystems naturally form what we call a pyramid of biomass. To put that into perspective, you need this massive, incredibly wide base of producers, basically plant matter, at the very bottom, just to support a slightly smaller group of primary consumers. And at the very peak, you can really only support a tiny number of top predators, like hawks or wolves, because there just isn't enough energy left, making it all the way to the top to sustain any more of them.
Now for our final piece of the puzzle, Section 5, the global carbon cycle.
While energy burns off and flows away, matter does not. A single carbon atom embarks on this endless global road trip. It constantly cycles among four main spheres. It moves through the living biosphere, plants and animals. It drifts up into the atmosphere as a gas. It dissolves into the hydrosphere, our oceans and lakes. And it even gets buried deep into the geosphere, way down in the Earth's crust and soil.
And here is how it actually moves between those spheres. The exact same matter is endlessly rearranged through four major processes. Photosynthesis pulls the carbon in from the air. Respiration breathes it right back out. Decomposition breaks dead matter down into the soil. And finally, combustion, like when a forest burns or we use fossil fuels, releases it back into the atmosphere. It perfectly proves the rule that atoms are never created or destroyed. They're just passed around the planet's ecological engine over and over again.
So if you remember absolutely only one thing from this entire explainer, make it this. In any ecosystem, matter loops infinitely while energy flows continuously in a single direction. Say it with me. Matter cycles, energy flows.
But, this leaves us with a truly fascinating question. If the literal atoms that make up your body right now have been perfectly recycled since the dawn of the planet, where exactly does all the energy that powers them, like the energy radiating off you as heat this very second, eventually end up in the universe? Think about that next time you step outside into the sunlight. Thanks so much for joining me on this explainer, and keep questioning how the world works.